Thank you very much for introduction. So, unfortunately, my computer is very tired recently, same as me. So sometimes my microphone doesn't work. So in such case, Yamaguchi-san, please let me know. Sorry.
Sure, no problem.
And because I'm in office, so I have to wear a mask. Okay, let me share my presentation. Is it okay, Yamaguchi-san?
Yes, we can hear us, see it fine. Thanks.
Yeah, okay, let me start. So, good afternoon, everyone. So my name is Kengo SHINOMIYA from Kyudenko Corporation. So we are enhancing the stabilization of renewable energy on microgrid at remote islands by our original energy management system technology. So it's our pleasure to introduce our activity today. So Kubo-san has already introduced our activity on his session. So I would like to explain more detail. Thank you for this opportunity. So we are demonstrating our EMS energy management system at Sumba Island. You can see this picture. So Sumba Island is located in East Indonesia. So we have built up this demonstration in December year 2017. Based on the scheme of financing program to demonstrate the decarbonization technology for realizing co-innovation, supported by Ministry of Environment and JEC. So at first, please let me introduce a little bit about our company. So Kyudenko headquarters is located in Fukuoka City. Fukuoka City is located in west side of Japan. So our main business is electrical construction and facility construction like air conditioning, piping, mechanical area, and so on. So Kyudenko belongs to Kyushu Electric Power Company Group, and also providing a power distribution line work. About renewable energy area, so we have many experience of construction for solar power, also wind and biomass plants. So total construction volume is over 2,200 megawatts in Japan domestic right now. So this is some data of our company. So we have a 77 years history. So our network in foreign countries is where? Anyway, we have office in Singapore, Indonesia, Vietnam, Thai, Malaysia, and Taiwan. So move to explanation of our Sumba demonstration site. So this picture is showing some pipeline of our energy management system. So you can see the graph on the side. So this is just an image of input from solar modules. So solar modules receive sunshine and make electricity. So, but depends on whether output from generator does not keep same level. So like this figure. So if system sends electricity to power conditioner directly, the wave should be how to say shaking. So this green color area is some our symbolic figure. So by our EMS system, swinging output from PV module is stabilized by our software system and sending to a grid, and some part of electric energy will be stored into battery. So because Kyudenko is construction company, so we are flexible for type of battery. So, but usually we are using lead acid battery here, and due to some reasons. So firstly, still, lead-acid battery has cost advantage, and this battery technology has a next generation roadmap from technical point of view. Secondly, lead-acid battery is safety compared with lithium. So it's very lower risk of fire and explosion. So our idea is that to put the battery in some remote island area. We selected this type of battery. So thirdly, recycle flow is of lead-acid battery is built up already. So because the lead-acid battery is very popular in automotive application. Okay. This is some difficult slide, but this is overview of our demonstration site at Sumba Island in East Nusa Tenggara State in Indonesia. So since 10 years ago, BPPT, so BPPT, who is one of government agency in Indonesia, has own demonstration site at Sumba Island to study solar power and storage system. So Kyudenko and BPPT had long discussion from year 2015 about their next target, which is microgrid control. Then BPPT and Kyudenko both agreed the implementation of EMS system, Kyudenko EMS system, onto existing Sumba demonstrating site. So left side is original demonstration system by BPPT and renovated to new demonstration system as right side. So keeping existing PV solar modules and totally removed all the battery. Here there was some this is the redox flow type battery. Removed two lead-acid battery and changed all power conditioner equipment to Kyudenko EMS system. So today this demonstration site has been sending about 200 kilowatt-hour electricity to West Sumba PLN grid. So this is a real transmission record of our demonstration site. So you can see a blue line here. Blue line is input level from solar module. So due to weather, level should be not stable. So our EMS managed rectification inside and transmit as yellow color line. So consistently output level is keeping flat. This is advantage of our EMS system. Okay, so this is somehow technical slide, but another view of our EMS performance. So upper side is the normal type of transmission figure of solar power generator. So of course, sunshine should be peak at noon and going down in evening time. So using our EMS system, transmission to the grid, this amount should be keeping flat. This is a very simple figure of our system. Okay. Okay. So please let me summarize EMS introduction. So it was so challenging for us to build up our site far from our home ground. So because we are living in Kyushu Island, Japan, so there are a lot of islands, and we have many experience there. So therefore, we believe that our technology can somehow contribute for Indonesia also. Because Indonesia has more number of islands and microgrids. So that is the reason to start our demonstration. So however, introduce our technology, paper-based was not enough, we think. So we have to show real power generation by our EMS. So there were two options. One is to invite Indonesian people to our Kyushu, Japan. Another one is to make our site in Indonesia. So according to kind cooperation with BPPT and the co-innovation program by Japan government, so finally we could make this demonstration site. So next step is our commercial opportunity of renewable energy generation. So we have been planning several projects. So our final goal is to achieve 24 hours electricity supply by renewable energy only. Okay. So this is a final page of my presentation. So this is one of our plans at somewhere remote island in Indonesia. So above here is actual grid network. So mainly electricity supplied by a diesel generator, two system of diesel generators. And but there are some small-scale solar power managed by ESDM and PLL. So if so, we are trying to innovate by our EMS also. So, but if power source is only solar power, still it's difficult to cover 24 hours demand. So, therefore, so some diesel generators should be remain as base load source here. So on the other hand, PV and the battery, so you can see this large size lead-acid battery, about 32 mega on this plant. So this battery and PV can about 40% reduce the number of diesel generators. So here, here there is some about 2.8 megawatt actual diesel generator, but switching to EMS system, so we can achieve some peak system. So this diesel generator can be transferred to another area, another location. So we are proceeding this plan and hopefully JCM program applied to this plan in near future. So thank you very much for your kind attention, and sorry for my poor English. That's all. Thank you very much.